Let's talk about right triangle trigonometry. This is basically related to the fact that with a right triangle, if you know another angle, any right triangle with that same angle will be similar. All of those would be similar if they have the same angle. So what trigonometry has done is a couple different ratios related to these right triangles. So if we're referring to this angle, we have the hypotenuse, but regarding this angle, we can say that this side over here is the opposite side, and then down here between the angle and the right angle is the adjacent side. Adjacent just means next to. Alternatively, if we're looking at the other angle, this is still the hypotenuse, but now this is the opposite side, and this between the two angles, the right angle and the given angle, that's the adjacent side. So the ratios are just based off of what the angle measure is. Typically they'll use the Greek letter theta to represent an angle. And the three trigonometric ratios are sine, cosine, and tangent. Sine is it's abbreviated SIN, is the ratio of the opposite side to the hypotenuse. Cosine, abbreviated COS, of an angle is the ratio of the adjacent side to the hypotenuse. And tangent, abbreviated TAN, of an angle is the ratio of the opposite side to the adjacent side. And then the angle that we're given just determines which sides are opposite and adjacent. Now a common way to remember these ratios is SOHCAHTOA, which is just a mnemonic to help you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's take a look at some of these ratios for some triangles that we're already familiar with, 30, 60, 90, and 45, 45, 90 triangles. For the 30, 60, 90 triangle, we know that the short side over here, we'll just call it X. The hypotenuse is double the short side, and the long leg is times the square root of 3. The short leg times the square root of 3. So if we were using these values, we could come up and write the sine of 30, cosine of 30 degrees, and the tangent of 30 degrees. Remember SOHCAHTOA, where sine is, so if we're using the 30-degree angle, this is opposite, and then the long leg would be adjacent. Sine is opposite over hypotenuse, so it would be x over 2x which is 1/2. The x's would cancel out. Cosine is adjacent over hypotenuse, so it'd be x squared root of 3 over 2x. Again, the x's will cancel out, and we would reduce that to be square root of 3 over 2. And last, we have tangent, which is opposite over adjacent, x over x square root of 3. Again, the x's cancel out, so we're left with 1 over the square root of 3. But you're not supposed to have square roots in the bottom, so when you multiply by square root of 3 on top and bottom to get rid of it, we're left with square root of 3 over 3. And if we flip it, and now we look at the 60-degree angle, now the short leg is the adjacent, and the long leg is opposite in reference to the 60-degree angle. So sine of 60, opposite over hypotenuse, that's x squared root of 3 over 2x, which we already simplified previously to be square root of 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse, x over 2x, which we've already simplified to be 1/2. And tangent of 60 degrees is opposite over adjacent, x square root of 3 over x. So the x's would cancel out, we're just left with square root of 3. Over here for our 45, 90, we know the two legs are the same, and the hypotenuse is times the square root of 2. So if we use, it doesn't matter which angle we'll take, but if we use our top angle, this would be opposite. This side is adjacent, but they're both the same, so it doesn't really matter. And then we have the hypotenuse, x times the square root of 2. Opposite over hypotenuse would be x over x times square root of 2, which if we use the same trick we did to get rid of the square root in the denominator, multiply by square root of 2 on top and bottom after we cancel the x's, we would get 2 on the bottom and a square root of 2 on top. Cosine of 45, adjacent over hypotenuse, those are the same values, so we again get square root of 2 over 2. And then tangent of 45 degrees is opposite over adjacent, x over x, which is just 1. We can use trigonometry to measure objects indirectly. For example, if we measure the angle looking up to the top of a building, and we know how far away you're standing from the building to create that angle, you can calculate the height. So if the angle of elevation is 21 degrees, we can find the height knowing that we're 150 feet away. The height of the building is the opposite side, and our distance is the adjacent side, so we have opposite and adjacent. That goes with tangent. So we're going to use tangent of 21 degrees equals opposite over adjacent, x over 150. So to be able to solve this problem, you have to know what tangent of 21 degrees is. And then we'll multiply by 150 to find out what x is. So we multiply by 150 times tangent of 21 degrees. So in order to get what tangent of 21 degrees is, you can use a chart that you can actually print charts that have all the tangent ratios, all the sine, cosine, and tangent ratios, or you can use your calculator. So on most calculators, you'll find sine, cosine, and tangent. Calculators vary, but you do need to make sure that you're in degrees if you're going to be entering 21 degrees as our angle. So we need tangent of 21, which is a decimal, and we need to multiply that decimal times 150. So we get x equals about 57.6. And that will be feet because our other distance was in feet. Now you can also use trigonometry to figure out angles, and that's what the inverse trigonometric functions are for. So if we had a triangle like a right triangle that was 5, 12, 13, and you want to find out what one of the angles were, you can use any of the inverse trigonometric functions. So if we wanted to find this angle, theta, we can use the 5 as our opposite side, or the 12 as adjacent, and the 13 as our hypotenuse, because that's where they are relative to the angle we're trying to find. So we would know that sine is opposite over hypotenuse, 5 over 13. Cosine of the angle is adjacent over hypotenuse, 12 over 13. And tangent of that angle is opposite over adjacent, 5 over 12. So going back to our calculator, if you want to find out what the angle is, you have to do the inverse function, which is normally the second function above regular sine, cosine, and tangent. So you need to push the second button to access the writing above the buttons, and then input the fraction, 5 over 13. So we get that it would be 22.6 degrees. And it should be the same for all of these ratios, so let's do the inverse cosine of 12 over 13. It is the same. And tangent, we could do inverse tangent of 5 over 12. And again, it's the same as it should have been. So the angle is 22.6 degrees. So we're going to take a look at two theorems related to sine, cosine, and tangent. First is tangent is the same as sine over cosine. And our second theorem is sine squared plus cosine squared of the same angle equals 1. Now let's look a little bit deeper at those theorems by using a 3, 4, 5 triangle. If we pick an angle, angle A, sine would be opposite over hypotenuse, 3/5. And cosine of that angle would be adjacent over hypotenuse, 4/5. And tangent would be opposite over adjacent, 3/4. Now if you take sine over cosine, like our first theorem on this page says, we would get 3/5 over 4/5. And whenever you're dividing a fraction by another fraction, you flip the second fraction and multiply. So the 5s would cancel when we work it out. We get 3/4, which is the same as tangent. So tangent is sine over cosine. Also, we can look at sine squared plus cosine squared equals 1 by taking sine is 3/5, cosine is 4/5, when you square 3/5 you get 9/25. 4/5 squared is 16/25. Add those together, that's 25 over 25, which is 1. Exactly what we were asked to verify. So we can also use those theorems to figure out cosine if you know sine, because sine squared plus cosine squared equals 1. If sine is 0.5736, we just need to square it and subtract it from 1 to determine what cosine squared equals. So 0.5736 squared is 0.329. Subtract that from 1. And we get 0.671. And that equals cosine squared. So to solve, we have to take the square root. And we get cosine equals 0.8191. When a problem says to solve the right triangle, that means you're finding all of the missing sides and angles. So if we have a 90-degree angle, we can do sine, cosine, and tangent. But also if we know one of the acute angles, we can find the other, because the three angles have to add to equal 180. So if this is 90, this is 43, the third angle has to be 47, because it has to all three add to equal 180 degrees. Then we know the hypotenuse, so we're going to want trig functions that use the hypotenuse, like sine and cosine. We're not going to use tangent because we don't want to relate two things that we don't know, opposite and adjacent. So sine of 43 degrees is the opposite side, A, over the hypotenuse 14. Also, we can go ahead and set it up. Cosine of 43 degrees is the adjacent side, B, over the hypotenuse, which is 14. So if you pull out a calculator, you can do sine of 43, get that decimal, multiply by 14 to solve for a. So we get about 9.55. And then for the other part, to find b, we need cosine of 43 times 14 cosine of 43 is 0.73. Multiplied by 14, we get 10.24. For another example, we have to solve the right triangle, but this time we're given two sides. So let's start by finding one of the angles. So let's start by finding angle A. Since we know, related to angle A, we know the opposite and the adjacent side, we're going to want to use tangent, because SOHCAHTOA, the one that has both opposite and adjacent, is tangent. So we're going to set up a tangent expression. Tangent of A equals opposite over adjacent, 7/9. And then to find an angle, that's inverse. So we'll do inverse tangent of 7/9. It's 37.9 degrees. So we can find the other angle by subtracting from 180, the 90 degrees, and the 37.9. And we get 52.1 degrees. Then to find the missing side, we can do Pythagorean theorem. 7 squared plus 9 squared equals c squared. That's 49 plus 81. So we get c equals about square root of 130. And that's it. We found the two missing angles and the missing side. We can also use trig to help determine the area, because we can use it to get the height. So we do have that this is a 50-degree angle. We want to find the height if the hypotenuse here is 35 millimeters. So that's opposite the 50 degrees, and this is the hypotenuse. So we're going to be using sine. So on the calculator we need sine of 50. And we will multiply that by 35 to solve for h. So our height is 26.8. The base is 75. So our area is 1/2 75 times 26.8. Multiply all of that out, we get about 1005. Since the units here were millimeters, we found area, we multiplied, so we got millimeters squared. Another very useful way to use sine, cosine, and tangent is law of sines, which states that the sine ratio of an angle is proportional to the side that's opposite that angle. So we have sine of A over A equals sine of B over B equals sine of C over C. Or you could invert all of those. So we are going to take sine of the angle over the side. So we have sine of 45 over the side length that's opposite is A equals sine of 30 over the side that's opposite at 5. So to solve this, sine of 45 is square root of 2 over 2. Sine of 30 is 1 over 2. So we have 0.5a equals 5 square root of 2 over 2. To get rid of the 1/2, the 0.5 or the 1/2, you have to multiply by 2, which will cancel out the denominator. We get a is 5 square root of 2. So next we have the law of cosines, which is a little bit more complicated, but it says that one side squared equals the sum of the other two squared minus 2 times those other two sides times the cosine of the angle, the original angle. So to find the side length A in this triangle, we do know the two other sides and one angle, the angle that's opposite the side we're trying to find, so we will use law of cosines. So a squared equals 6 squared plus 7 squared. Minus 2bc, so 2 times 6 times 7 times cosine of the angle 30 degrees. So that's 36 plus 49, it's 85, minus 2 times 6 times 7, times cosine of 30. So we need to subtract the 72.75. Subtract that from 85. And we get 12.25. So that's a squared, so we need the square root. 3.5.